Hello students. In last video we have discussed about the monotonicity of the sequence, monotonically increasing sequence, monotonically decreasing sequence, and some results related to the convergence of monotonic sequence. Like if sequence is monotonically increasing and it is bounded above, then sequence is convergent. Similarly, if sequence is monotonically decreasing and it is bounded below, then it is uh, convergent sequence again. And if sequence is monotonically increasing and it is unbounded above, then it is diverging to infinity. And if sequence is monotonically decreasing and it is bounded below, unbounded below, then it will be a diverging sequence, diverging to minus infinity. So today we will discuss the few examples related to the monotonicity of the sequences. So the very first example is xn. Here we will just examine the monotonicity, whether sequence is increasing or decreasing. So there is a particular way to prove this, that the sequence is whether it is increasing or decreasing. So we will discuss it that particular way. So given xn is 2n plus 7 divided by 3n plus 8. So here we will apply the definition of monotonicity. As we know, if xn plus 1 minus xn is greater than 0, means if later terms minus previous term, if its difference is greater than 0, if its difference is positive, then obviously function is sequence is increasing. It is like x1, x2, x3. Suppose this is a sequence xn plus 1. So when would we say that sequence is increasing? If this term is greater than this, no? If later term is greater than previous term. So if x3 is greater than x2, means xn plus 1 is greater than xn. That means xn plus 1 minus xn is greater than 0. If this holds for all n, then we say that sequence is increasing sequence. And what will be the result if xn plus 1 minus xn is less than 0? Obviously this is increasing sequence. And if this term is less than this, means these terms are decreasing, right? The value of the terms are decreasing. So in that case, the sequence is decreasing sequence. So these are the obvious results. If it is strictly greater than 0, then it is strictly increasing. If strictly less than 0, then it is strictly decreasing. So this is the concept we will use here in order to prove that, in order to check the in order to examine the monotonicity of the sequence. So here I will use this concept. I will check xn plus 1 minus xn. What will be its value? So this is xn. Here xn equals to 2n plus 7 upon 3n plus 8. xn plus 1 equals to, I will just replace n by n plus 1. So 2n plus 1 plus 7 divided by 3 into n plus 1 plus 8. So this is our n plus 1th term. So it will give 2n plus 2 plus 7 is 9 divided by 3n plus 3 plus 8 is 11. So this is our n plus 1th term. So if I subtract xn plus 1 minus xn, I will get 2n plus 9 divided by 3n plus 11 minus 2n plus 7 divided by 3n plus 8. So I will have to take the LCM first. This is 3n plus 11, 3n plus 8. So multiplying this 2n plus 9 with 3n plus 8 minus 2 2n plus 7 with 3n plus 11. This is just a simple operation, simple subtraction, nothing else. So I will multiply this, open this brackets. 2n into 3n is 6n square. 8 into 2 16n, 9 into 3 27n, sorry, 27n, and 9 into 8 72 minus 2 into and 2n into 3n is 6n square again. 2n into 11 is 20, sorry, again it is minus 22n. 7 into 3 minus 21 and 7 into 11 sorry, again minus 77. So whole divided by 3n plus 11 into 3n plus 8. So here we get, now see this 6n square plus minus cancels. Now 27 plus 16 is 43. 21 plus 22 again is 43. So this is plus 43n and this is minus 43n. So this also cancels, right? So we are remaining with 72 minus 77 is minus 5. Clearly in numerator there is only a constant term minus 5, and in denominator we have 3n plus 11 and 3n plus 8. Now what can you conclude from here? Now see, in numerator we have constant value minus 5, and in denominator we have 3n plus 11 into 3n plus 8, where n belongs to natural number, right? N belongs to natural number. So there is no chance of denominator to be negative, right? So the whole sign, that only depends on the numerator, because it is a positive term. 3n plus 11 is also positive because n is a natural number, so it will never be negative. Again 3n plus 8 is also positive value. So the sign depends on the numerator. So here in numerator we have minus 5. So clearly the whole expression is negative, less than 0. And this holds for all n belongs to natural number. Right? So here what we get clearly, since xn plus 1 minus xn is less than 0 for all n belongs to natural number, that is xn plus 1 minus xn plus 1 is strictly less than xn for all n belongs to natural number. This implies sequence xn is monotonically decreasing sequence, or we can say strictly decreasing sequence, right? So this is the way we can prove whether we can check whether a sequence is monotonically increasing or it is monotonically decreasing. So see what we have done. We have taken this xn. So first we find xn plus 1, then we subtract both these terms, and finally we get this subtraction, this expression is strictly less than 0. Now what it means, xn plus 1 minus xn is strictly less than 0. This implies xn plus 1 is strictly less than xn. So the terms comes later are greater than the previous term. That means sequence is monotonically, the term comes later are less than the previous terms. The term are less than its previous terms. So that means this holds for all natural number, means x1 is x2 is less than x1, x3 is less than x2, or I can, if I want to write it, in a proper way, then I can conclude that this condition holds, right, and get so on. So what is the meaning of condition? This condition means the sequence is monotonically decreasing. So वैल्यू डिक्रीज कर रही है, x1 की सबसे बड़ी है, फिर x2 की, फिर x3 की, एंड सो ऑन, राइट. So I hope the idea is clear. So let us move to the next question. Very important. Show that this is another type. Now here we don't want to examine whether the sequence is monotonically increasing or it is monotonically decreasing. We just want to prove that the sequence is convergent. So the question is, show that the sequence xn is convergent. Now we will use the concept of monotonically increasing and decreasing sequence. Only in that way we will prove that sequence is convergent. As we have already discussed in previous video, that any monotone sequence is convergent. So we have discussed the conditions for a monotone sequence to be convergent in detail in the previous video. In that lecture, we discussed 4 points. The first 2 points are related to convergent sequence, and other 2 points are related to divergent sequence. So I will revise those points. First 2 points. A monotonically increasing sequence is convergent if and only if it is bounded above. Please listen carefully. I am repeating. A monotonically increasing sequence is convergent if and only if it is bounded above. Right? So now if we want to prove that this sequence is convergent, so first of all we will check whether it is monotonically increasing or decreasing. Second point is, a monotonically decreasing sequence is convergent if and only if it is bounded below. So first of all we will check whether this sequence is monotonically increasing or decreasing. If it is monotonically increasing, then we will check whether it is unbounded above or not, right? So if it is monotonically decreasing, then we will check whether it is bounded below or not, right? If both the conditions will satisfy, then we can say that this sequence is convergent. Now let us check. Now as we know, we have discussed in previous example how to prove a monotonicity. So this was the particular case of decreasing sequence. Now let us check what will be our what can we say about the monotonicity of this sequence. Right? So this is the xn. So let us find xn plus 1. So simply I replace n by n plus 1. So I will get n plus 2, n plus 3, and so on. In the last we will add 2n plus 2, not 2n plus 1. I will put n here in the bracket, replacing n by n plus 1. Now see, there is a difference. You cannot write its nth term as 1 upon 2n plus 1. That will be wrong, right? So this is the common mistake normally generally students do, right? So don't repeat this mistake. So I will simply replace n by n plus 1. When I will replace n by n plus 1, then I will get 1 upon 2n plus 2. See it carefully, observe it, right? So this is the nth term. So now I will subtract xn plus 1 minus xn. So on simply subtracting these terms, what will I get? This term will be cancelled. This minus this minus this, and so on. Or the previous term will be 2n. So this will be also be cancelled, and I will be remaining with 1 upon 2n plus 2 minus 1 upon n plus 1. So let me check whether it is positive or negative. So if I take common 2n plus 1 minus 1 upon n plus 1. So what is the intuition? This is half of this number, right? So idea is clear that it will be negative. So let us prove it. The LCM will be twice of n plus 1, right? So previous question was also decreasing. Okay, so here again we have a decreasing sequence. So we have 1 minus 2, which is negative of 1 upon 2 into n plus 1, right? So this is again negative number for all n belongs to natural number, right? So therefore xn is monotonically decreasing sequence. Right. Now it is decreasing sequence. Now can you guess, in order to prove that it is convergent, what will be the next step? What we have to prove? Second condition. Now take some time. The sequence is monotonically decreasing, and we want to prove that it is convergent. So the obvious condition we will prove here is that xn. Now just take a time. Now to prove that sequence is convergent, we need to prove that, yes, I hope at this time you are clear what we are going to prove. We need to prove that sequence is, yes, it is bounded below, yes, right? So in order to prove that sequence is convergent, it is monotonically decreasing sequence, or if it is decreasing, then we need to bound it from lower side, bounded below, then it will be convergent. Okay, so now we will prove the sequence is monotonically, it is bounded below. Now in order to prove that sequence is bounded below, we will simply oh sorry, there is some mistake. Okay, yes, there is some mistake here. I need to rectify it. So let me correct first. Actually, what we have missed here, the previous term will not be 2n, because it is increasing 1 by 1, n plus 2, n plus 3, and so on. So previous term should be 2n plus 1. So here I have done a mistake, so I will rectify it. 1 upon 2n, 1 upon 2n plus 1, 1 upon 2n plus 2. Because how I came to know that, because I have I have written here 2n plus 2. So there is only increase of one number. Here it is n plus 2, next is n plus 3, not n plus 4. So I have subtracted 2 points, but I have missed one term. So 2n plus 2, so 2n plus 1, and then 2n. So when we will subtract, I will get two terms here, 2n plus 1 minus 1 upon, and last term is n plus 1. So when we will subtract these terms, so we will get a different result. So let me first take LCM. 2 into n plus 1 into 2n plus 1. So n plus 1 is LCM, 2 into n plus 1 into 2n plus 1 is LCM. So if I multiply these terms, here I will get 2n plus 1 plus 2 into n plus 1 minus 2 into 2n plus 1. So that will be equal to 2n plus 1 plus 2n plus 2 minus 4n minus 2 whole divided by 2 into n plus 1 into 2n plus 1. So this will be equal to, sorry, there is some mistake, I need to rectify it. So 2n cancel, 2 cancel, and here the answer is 1 upon 2 into n plus 1 into 2n plus 1. So it is a positive term. So this is positive for all n belongs to natural number, and whole idea is changed now. So इसको हम थोड़ा सा चेंज कर देते हैं. Let me take it to down, and here I will write sequence. Therefore sequence xn is monotonically increasing sequence, right? Monotonically increasing sequence, because xn plus 1 xn is strictly greater than 0. Numerator is 1, denominator is positive. So in order to prove that sequence, we need to prove that sequence is what? Bounded above, because it is now increasing. So when I started thinking about the bounded below condition, then it was very obvious that it is a term. These are positive terms. So bounded below प्रूव करना easy है. तो तब मेरे दिमाग में थोड़ा स्ट्राइक किया कि कुछ मैंने गड़बड़ की है. तो कोई बात नहीं, हो जाता है कई बार. सो अब हम इसको प्रूव करते हैं that this sequence is bounded above, because there is something new in to proving this sequence as bounded above. Bounded above प्रूव करना मुश्किल है, bounded below प्रूव करना आसान है, because it is the sequence of positive terms and xn is greater than 0. So this is greater than 0 for all n belongs to natural number. So obviously it is bounded above, bounded below, right? So it was not difficult to prove that this sequence is bounded below. Then something strike to my mind that I have done something wrong. So let us prove that this sequence is bounded above. Now take the xn. Here we go. Xn equals to 1 upon n plus 1, 1 upon n plus 2, and so on, 1 upon 2n. Now see, this term is less than equal to. Now can you observe that which term is the largest term in this sequence? Out of 1 upon n plus 1, 1 upon n plus 2, and so on upon 1 upon 2n. Which term is largest? That term is largest whose denominator is small. Now 2n is small or n plus 1 is small? Obviously n plus 1 is smallest denominator. 2n is large, right? So because this the denominator of this term is smallest, therefore it will be the largest term of this sequence, of nth term, right? So ये क्योंकि largest है, so if I replace all the terms by n+1, राइट. सो ये इससे बड़ी है, ये अगले से भी बड़ी है, ये 2n 1/2n से भी बड़ी है. तो इसको मैं लिख सकता हूँ ग्रेटर लेस देन इक्वल टू 1/n+1, 1/n+1. सो मैं आई हैव रिप्लेस्ड ऑल द टर्म्स बाय 1/n+1. It is like I have written 1 plus 2 10 plus 9 plus 8 and so on plus 1. If I replace the largest term, then I can write this is less than equal to 10 plus 10 plus 10 plus 10 plus 10 times, right? I can write this. So if this is the largest term, then and I replace all the terms by this term, then obviously this sum will be less than equal to this sum. Please observe this. Please observe carefully what I have explained here. I have write 10 plus 9 plus 8 up to so on 1. Now I replace all the terms by 10. 10 instead of 10, and I am writing, sorry, 10 is same. Instead of 9 I am writing 10. Instead of 8 I am writing 10. Instead of 7 I am writing 10. And instead of 1 I am writing 10. So if I replace all the terms by 10, then obviously this sum will be greater. This sum will be greater. So here I am doing the same thing. I am replacing the largest term. Now you need to observe why it is largest. As I have already explained, because the denominator of this term is smallest, so this is largest. Means 1/2, 1/3, 1/4. जैसे जैसे डिनोमिनेटर बढ़ता जाएगा तो टर्म जो है वो छोटी होती जाएगी. सपोज यहाँ पे 1/n है. अगर मैं इसको रिप्लेस कर दूँ 1/2, 1/2, 1/2, तो ऑब्वियसली ये टर्म बड़ी हो जाएगी. क्यों? क्योंकि मैंने 1/3 को 1/2 से रिप्लेस कर दिया, 1/4 को भी 1/2 से रिप्लेस कर दिया, तो 1/2 इन सबसे बड़ा है. तो अगर मैं इनको n टाइम्स रिप्लेस कर दूंगा तो ऑब्वियसली ये सम जो है वो बड़ा हो जाएगा. सो सिमिलरली आई हैव डन हियर, राइट. So I hope the idea is clear. So this is 1/n+1. Now how many terms are there? These are n terms. So I have added 1/n+1 n times. So that will be n/n+1. And this term is strictly less than 1 because numerator is small and denominator is large. So this term is strictly less than 1. So xn, this holds for all n belongs to natural number. So xn is less than 1 for all n belongs to natural number. Therefore, sequence xn is bounded above. We have found a real number such that all the terms are less than that real number. Therefore, xn is bounded above. See, we are using just definitions of all the basic concepts. Means only we are using definitions. What is bounded above, what is convergent sequence, what is monotonically increasing sequence. So here first we prove that it is monotonically increasing, and next we prove that it is bounded above. So in combining these two statements, so xn is monotonically increasing and bounded above. Therefore xn is convergent. Right? So I hope the idea is clear. Now here we have not proved that what is the limit of this sequence. We have not find the limit of the sequence, to which number it is converging. So if we have to prove that this sequence is converging to some limit L, then we cannot use this way, because here we have just proved that it is a convergent sequence. We have not proved that it is converging to some limit L, right? So this method will be used only when we need to prove that this is a convergent sequence. So if we want to prove that it is converging to some limit L, then we will use some other ways. Okay, so I hope the idea is clear, right? So आज के लिए इतना ही है. Then I will come with the another video very soon. Thank you.